I want to start by telling thanks to Michael and Vivek sir. So a couple of things, right? So all work we do day by day. End of the day, we want to do it because it has to help people. So it is good to see that at the scale we, over the years, right, the stacks and things which have helped the people to utilize the digital world in their day-to-day life. So, and with that, the next word which comes to my mind in the initial talk is interoperability and the actual standards. So they are critical in, the standards and interoperability is the word now, right? So because we are moving towards more of, what do you say, an open world or more collaborative development. Even though most of us are from different companies, we use mostly some component of our products would be using something open source, something developed by different people, or we develop it as a single, we develop it as a common aggregated development as a project. So I'm waiting for the clicker. At that time, I just wanted to talk a little more. So one, I'll be talking mostly about open hybrid cloud today, and I'll just touch upon how Gluster fits it as a right storage for all this. So yeah, the thing is, we'll go through what hybrid cloud needs, and then what are the things coming up and how Gluster fits the bill. So what is the hybrid cloud? So how many of you here use or depend on cloud for your activity? Not on-premise or not your storage as in local storage. Cloud. You operate on cloud on a day-to-day basis. That is maybe 10%. That's interesting, but I have data that a lot more people are moving in that direction, right? So a hybrid cloud is, by definition, one or more public and private cloud being involved, right? So it is a combination of both public and private cloud in your setup. And the way pictorially, if you want to understand how it looks, it's more of most of your operations depend or work in one public cloud, private cloud, or different public cloud providers and things like that. It may be your containers platform also, right? And the key word to look here is there should be a degree of interoperability, because you can't have a setup where, my application only runs in this setup, but like I can't move it to the other setup so quickly. That's the key word, and it should need a common management part. So why hybrid cloud is critical, right? So if you look at the data provided last year, 62% of the people are saying that they will move or they're already at the hybrid cloud setup, where they want to move towards either two different public clouds, or they want to have their own private cloud and move to public cloud also, certain workloads and things like that. And only 38% want to be in the single cloud provider. So if you look at hybrid cloud, what is the keywords you would take away, right? What does the keywords which make a hybrid cloud? First thing is interoperability. Second, unified management. Third, it should scale. I mean, scalability is the reason people would move to cloud, right? So they don't know how much they should invest upfront, so they want to actually take it as it goes. So that's the reason why they want the application and everything involved with the stack, right? So to be scalable. So that is the keyword. And data portability. So that is the key thing here. So, and that does matter a lot for us as a developers being here in the storage world, right? So data portability will be the key word for the future for us. So why all of this I'm talking about all of this, right? So things have changed over the years. I mean, it is for the good, I believe. Is like in the old order, it was like, okay, we had system admins, we had different admins. I mean, your data admin may be different, your storage admin is different, your sys admin is different. So each of them had different things to take care of, right? So with the new order, it is different. You have a DevOps team, they deploy end to end, like they decide what to do. So it is much smaller team, they deploy much faster. I mean, as a developer, you would not know when it would be deployed. You just commit and just wait. I mean, it may be deployed the next hour, or it may be next week, or things like that. So it is very critical that with the new model, all our stack is flexible and compatible with all these things. So why does it matter, all of this, for us as a storage developers, I believe, right? So what it means is our storage should have a scriptable or manageable, flexible management APIs. It is not enough that you just provide storage, right? So it's like, as a storage, how can I consume it also matters now, because DevOps team would script something, they need to have it and all that. FaaS, as in function as a service, right? So, I mean, if you don't know the word, it is more of AWS's Lambda services or Apache's OpenWhisk and things like that, right? Where people would want to do very specific thing, maybe event driven or things, so just like get it done and just wind up. So why it matters most is whatever service it is, end of the day we'll hit some storage at the later. It may be small object, it may be big object, it doesn't matter. So it may be its config file itself, but it needs that. So if it is just leaving for a few minutes or a few seconds, right, it still needs a storage. So your storage lifetime itself, as a volume or whatever you have, all of that needs to be different. That's what is my next point, which is scalability, right? Your storage need. I have put 1 GB as a volume size, but a single file can be few kilobytes or even bytes to whatever size it is, right? So your scale of a storage today is expected to be very different. Different users have different needs, different like companies, different applications have different needs. So you have to be very flexible with your volume sizes and also the duration of the time your data resides on the storage. So all of that is the varied demands. And storage, for the good or the bad, I don't know, is becoming more invisible. Like if you ask new college grads, right, what is storage? I mean, how many courses do they have about storage? It's very hard. Like when I hire new guys, right, when we talk about storage, they don't know. I mean, they know that, okay, 128 GB is my phone storage. That's mostly the max they know, right? So other than that, they don't know how to access it. Application does it for them. So they don't know. They just take selfies or something, it gets stored, it gets synced to the cloud without their knowledge. All they have to do is click some button somewhere, done. So it is very, very critical that storage is becoming invisible, which means we have to provide all the required things for the storage by scripting or whatever. So there are a lot of things, and I call it one storage as in, I don't know, was it a keyword earlier or the new one, but yeah, there's our Red Hat storage view head recently wrote a blog where he was hearing some of the customers talk about, I think unstorage is a word for storage becoming invisible, right? So what it means, storage is nowadays living with its application. So it is more co-located with the application itself, and it is served out of containers, and it is dynamically provisioned, it is managed programmatically. You don't know, you don't have to click. There is no, like Vivek was telling, we don't need the people to be there. So that's a goal here. Like if you want a sysadmin or somebody to approve storage volume creation, then the whole purpose of dynamicity is lost. So, and it is managed by DevOps team and maybe cloud admins, and there is no storage admin silos anymore. Cool. So this is all the story. I mean, most of you would be already knowing it, right? So the marketing materials reaches you, okay, all these keywords, good. So, so it's all great, but now let's look at how a product would fit into the game, right? So why we believe Gluster storage specifically fits the bill is because of the reason that it can run on any of this, which is very, very critical when you move towards hybrid cloud. So It can run on bare metal on especially, of course, it has to be a Linux OS, and it can run on a virtual setup. It can run on top of containers as a container, and it can run in public cloud. It can, on top of legacy storage, if you have a sandbox, you can get the Gluster storage on top of that too. So that means your applications see just the Gluster storage regardless of where it runs. So that's the reason why we believe Gluster is a natural fit when you move towards a hybrid cloud where you don't want a vendor lock-in or specifically the cloud vendor lock-in, right? Because we don't want a monopoly of the cloud, especially, so of a single company, because that's what people fear. I mean, we giving the same point which came up with the other security or the privacy point. We don't want one person to have all our information. So that's the key thing. So Gluster is a natural fit because there is no hardware dependency. Again, it is a software-defined storage. It's not like you can make it flexible, you can make it programmable, use the programmability or the APIs provided. You can scale out on demand, and it has other properties. When I say software-defined storage, it has other properties to it, right? So as, of course, I showed here, it can run anywhere, as in it can be virtualized setup, containers, or the legacy storage. And specifically, it can actually have the scale of more than millions, right? Because it can have a volume size of 1 GB, which is mostly used today in our container customer setups, or it can be running in a volume size of few petabytes if you need a larger storage, where it may be for the video archivals or whatever, right? So that is a scale of 1 million plus. So that is huge. So it's not just that points in Gluster. It is about more scalable management layer also. It is not just about the file system which provides the storage. It is about the management API. We are moving towards REST APIs so that you can integrate well, you can script it well, and things like that. And we have an intelligent volume provisioner which understands, oh, we should make sure the high availability should be across different availability zone and not in the same availability zone and things like that. And the performance enhancements are coming up. So it is the problem with storage most of the engineers would face is, oh, okay, my storage works great for, say, streaming workload, right? Or sequential writes or sequential reads, and that's how the developer mindset will be. But what happens if it is a random I/O? So that's a big challenge over the years, normally the storage developers face. So it is very, very critical that we understand the use case well, we tune it for the use case and things like that. So it is critical. I mean, we can't have a storage which fits the bill just like that. We need some tuning for sure, but that's where we are getting to a little of the use case specific tuning and the performance improvement on that. So, of course, one of the next thing asked in the storage world is, okay, how do I access the data, right? So is it a file? Should I mount it? Oh, I don't need it. I need an object store. I need a S3-like interface or some other object store. Or somebody would come say, okay, I need a block. I need a EBS or a Google Cloud block or a regular SAN network, right? So all those, of course, you can get it with Gluster. So, and applications can choose what they need at the time of provisioning it. So because once it is provisioned, they can continue to use whatever it is. And Gluster, as of today, is integrated well with orchestration platforms like Kubernetes. So which is very key if you or your clients or your customers are moving towards more containerized workloads. Cool, so this is one of the hybrid cloud in action. One of our customers, I don't want to take the name, has implemented it something like this, right? So they have different as a baseline, like they have a VM on-premise, they run it on their storage. They have an OpenStack, which is for their private cloud, and they also have some applications running in Azure because they just don't want to be on just one public cloud. They have data on the AWS too. And on the base, it's all Gluster for them because that's what we provide through OpenShift platform. And it is managed by CloudForms and a Red Hat Fuse and 3Scale, both of which are for managing APIs and the managing integrations better in the cloud and mobile applications. They use all this and in a hybrid or a multi-cloud setup, right? So this is, they're happy, they are willing to share just this diagram with people because they are happy with it. So it is already working, as in, it's not like just a conceptual thing we are talking here. So people are deploying it like this, where they want to abstract out the storage requirements in their setups. So with that, I just want to talk a little technical part of this Gluster, which we are working to make sure the hybrid cloud story is even more stronger. So one thing is called stretch cluster. Not so much in India, not so much in US, but in Europe, EMEA, stretch cluster is a key thing, where the data centers may be separated by, say, 50 mile away cities, right? So because the countries are also very nearby, or like, it's not like East Coast, West Coast. It is like, oh, Singapore, India, so not like Asia, right? So they need a high available or disaster recovery options across these data centers. So the latency is not a big problem there. Ideally, if you look at the disaster recovery problems, that your latency was the biggest challenge. So in those setups, latency is not a challenge, but they need more of disaster recovery options. So that's one feature we are bringing with stretch cluster. We call it stretch cluster because we are treating it as the same cluster, but it's a little stretched. So things like that, and a Halo replication. So Halo, it's a word coined by one of our partnering company who developed the feature. It was there. They extended one of the highly available feature of Gluster, and this makes Gluster work across geographies for them, and they're happy about it. It's a biggest social media company which developed this feature and contributed upstream for us, and it is still, there is a lot of work to be done, but it is working already good for demos and basic POCs. To deploy in production, we are getting it ready and things like that. +1 scaling. So because once you have a cluster, the challenge with cluster scaling is most of them say, okay, you have to increase it by say, some percentage of the cluster. You can't just do by adding one node at a time or things like that. But the challenge with that is, in the cloud setup, as I showed earlier, right? If the DevOps team is managing it, they would not get all these points. They want to just script it, move ahead. And if one node goes down, or they want to just increase the storage capacity by just, say, 2%, 3% a day, because they want to grow as needed, right? They need to grow by a machine at a time. Right? They don't want to grow cluster to cluster. So they can't provision. So that's where I think need of growing by one node at a time is very important, and that is critical for us in the Gluster world too. So that feature is coming up. And we are bringing something called Cloud Sync, which is more of your archived data, cold and the frozen data storage from on-premise to cloud and back and forth and things like that without user knowing it. So that's a feature all about. And there's, of course, more features which we are trying to bring. And if you're using Gluster in any sense, you can request for features, participate in discussions and things like that in our upstream GitHub pages. So yeah, that's mostly it. So with that, I just want to thank you all. And if you want to be involved with Gluster, there are options. It is upstream, totally open source, and the community is out there. We are all part of it. You can discuss with us there on GitHub or IRC or whatnot, and you can write to us in the email list. And if you want to be part of the company, of course, you can, again, get in touch, okay? There are a lot of these options. Cool. And last but not least, yeah, if you specifically want to reach me, my ID is in the presentation. As Paul said, it will be available for download. Cool. Thank you. I think I didn't get a timing badge, Bob. Yeah. Yeah, I just try to keep it minimum. Yeah, sure.
How do you test for 8
Okay, that is the challenge. So it is 8 petabytes. Earlier, when we actually made the climb of number of machines we can go up to. So it was very hard, say 5 years back, because say we can reach up to 8 petabytes within just 128 nodes, which is well tested number of connections we can manage across the cluster. So yes, yes, yes. As in, the challenge is just the Gluster team alone will not have an infra inside Red Hat, but as a Red Hat, we do have something called a Scale Lab, which is available for anybody to loan and test it. So we do test it at that level. But as a disclaimer, I would say it may not be the edge data and things like that. Yes, it is. It has its own challenges, but we do test. And if you look at the density, a single node can host almost like 200 petabytes without a problem today. So if you look at it, it is just 200 into like how much? 8, somewhere around 16. Yeah, somewhere around 80, 128 nodes is good enough to get up to 16 petabytes. So it should be easy. So the performance is dependent on many factors here, right? One is what is your network bandwidth, like because if it is backend is 10 gig or 100 gig InfiniBand and things like that, and the type of disks and the density of disk and all that. And generally what we have noticed is we can confuse people with IOP numbers all the time. So it is, does that in reality be the true thing? What we have noticed is not really, in a way that your application work pattern, your applications, how they behave together with, because if you have a distributed storage like this, you're not using it for just one application, mostly. It will be accessed from multiple clients. It will be served from multiple clients. That is where it is, what we have seen is, if you plan it well, where you have so many clients, not just one client or two clients, if you have, say, hundreds of clients, you can max out the network. So, which is what normally we aim for in terms of the performance.
So do you have any benchmarks?
I think, yeah, we don't have it in upstream, especially because the code keeps changing, the release by release, it would be hard for getting it. But the Red Hat, I think we can provide you on the benchmark numbers, yes. Yes, best practices, of course, yes. I mean, that's the difference between Red Hat selling it as a product from a project upstream. So the best practices and tested setup use cases are the ones how we differentiate from upstream project. Most of our engineers, our responsibility is to get features, get the bug fixes upstream first. That's our goal. Like anything you see, it may be an issue in the product, but it will go get fixed upstream first. And the best practices, whatever gets cherry-picked, tested, things like that gets into the product. Yeah.
Question on the multi-cloud and hybrid cloud.
Yeah.
So when we talk about multi-cloud or hybrid cloud, and also we talk about performance.
Mm-hmm.
So would like to get your perspective on what are the kind of use cases where I want to have a multi-cloud, mm-hmm. and I'm running something on Amazon and something on Azure, mm-hmm. something on on-premise. Mm-hmm. Mm-hmm. Now, if you look at most of the applications with demanding very good performance, mm-hmm. and when we say this model where the latency challenges with respect to going over the internet,
correct.
Then the question is on what are the kind of use cases you see are suitable for the multi-cloud kind of deployment?
Yeah, it is interesting. So you are right in saying that not every application right now, the say time critical or say your banking transaction may not get there right now. So because of the challenges involved, the guaranteed acknowledgement, right? So it has to be a synchronous thing. It can't be just delegated and things like that. Whereas if you look at the overall ecosystem of the, at least the use cases we see, right? There are so many things on the background which happens. Not just the front thing which you would do just operation and want to be sure of, right? So a lot of things which happens in the background. For example, Vivek, just take the Vivek's example, right? So you have the other number. To create a new other number, they have to go check with so many extra, all the existing data. So those things has to be like, maybe distributed, maybe done background, so where only when the result is available, we'll get back the just the binary yes or no or success or failure to you. So those type of application is what gets into all this setup, where depending on the CPU, depending on the need, like people don't want to, plan for their storage needs or compute needs right away. That is what the major benefit of the clouds part is, right? So they have bare minimum things available all the time, whatever SLA all the time on the on-premise. They would, on demand, scale out, scale down things would happen on the cloud. So things like that is what is getting migrated today. So it may be, of course, we do have customers as banks, customers as travel companies, customers as, for example, things who book tickets or things like that, right? So they all have a lot of these things which has to be done on the background. So they have, migrate that set of data over hybrid cloud first. And most of the applications which are your mobile apps and things where after download, like for example, I will upload a photo, but is the same photo stored, a single copy? May not be, because it would have different screen sizes, different thumb sizes, everything created in the background. For one photo I upload, there may be 10 photos which are created in the application. So those things would happen in the cloud. So things like that. Thank you. Thank you, Udyan.